Okay, so to solve this problem, uh, we first encode the probability mass function as -2, -1, 0, 1, and 2 with their corresponding f of x's, or the probability mass functions, to be equal to 0 0.2, 0 0.4, 0 0.1, 0 0.2, and 0 0.1. The conditions are all the probabilities must be positive, and for the total, if you're going to add this, it should be equal to 1. So indeed, we have verified that this is a valid probability mass function. For letter A, we are asked to solve for the probability of x is less than or equal to 2. So what we're going to do is to solve for the probability of x less than or equal to 2. So the values included here would be what? So for less than or equal to 2, so that would include all of these values except 2. So less than or equal to 2 is the sample space. So all of the values are included. So that would be the probability for the sample space. And we know that the probability for the sample space is equal to 1. So this is equal to 1. So let's mark it red. Letter B. For letter B, we are looking for the probability that x is greater than -2. So what are those values greater than -2? So this is the same as, so everything except -2 is greater than -2. So this is 1 minus f of -2. So the values included here are 0.4, 0.1, 0.1, 0.1, or this is 1 minus 0 0.2. So that would be 1 minus 0 0.2. So that is equal to 0 0.8. How about letter C? For letter C, we're looking for the probability that the random variable x contains values in between -1 and +1 inclusive. So what are those values that includes -1 to 1 inclusive? So that would be f of -1, f of 0, and f of 1. So that would be equal to negative 1, that is 0.4, plus 0.1 plus 0.2. So the answer is 0.7. So 0.4 plus 0.1 is 0.5 plus 0.2 is 0.7. Letter D. For letter D, we're looking for the probability that the random variable x takes values less than or equal to negative 1 or x is equal to 2. So this includes negative 2, negative 1. So that would be f of negative 1 plus less than or equal to negative 1. So that includes negative 2, negative 1. What else? So less than or equal to negative 1 would be negative 2 and negative 1 and f of 2. So plus f of 2. So that would be equal to f of negative 2 is 0.2, f of negative 1 is 0.4, while f of 2 is 0.1. So that would be 0.7. Now, let's have the cumulative distribution function. So for capital F of x, so that would be equal to f of x is equal to, so that would be a cumulative distribution function. It should always start with 0. And then we're going to add the probabilities until we reach 1. So it would be 0, 0 plus 0.2. Next would be 0.2 plus 0.4, correct. And then 0.6 plus 0.1 plus equal to 0.7 plus 0.2. And then finally 0.9 plus 0.1. And then for their limits, we have x is less than negative 2, and then negative 2 less than or equal to x less than negative 1. So this, we start with negative 2, and then we have negative 2 to x to negative 1, and then this is from negative 1 to 0. Next would be from 0 to 1. So 0 is not negative. And then from 1 to 2. And finally, we have x is greater than or equal to positive 2. So this is our cumulative distribution function. So that. we have a follow-up question for that. We are going to apply probabilities. So for letter A, we're looking for the probability that x is less than or equal to 1.25. So this is equal to f of 1.25. What is 1.25? Where does it fall? One point 25 is here. So 1.25 is 0.9. So less than or equal to 1.25 are all values except 2, so that would also be equal to 1 minus 0.1. Correct. How about B? B is less than or equal to 2.2. So we're looking for the probability that x is less than or equal to 2.2. So this is equal to f of 2.2. What is f of 2.2? So I think it's the sample space. Less than or equal to 2.2. So everything is 1. So f of 2.2 is falling on greater than or equal to 1. So that is, it would be falling here. So it would be 1. Letter C. For letter C, we're looking for the probability that x falls in between negative 1.1 to x2 less than or equal to 1. So this is f of 1 minus f of negative 1.1. What is f of 1? So what is f of 1? F of 1 is, when x is 1, it is 0.9. So that would be 0.9 minus f of negative 1.1. Negative 1.1 is here. So that would be 0.2. So the probability that we're looking for is 0.7. And then for letter D, the probability that x is greater than 0. So greater than 0 is the complement of less than or equal to 0. So that is equal to 1 minus f of 0. So f of 0 is 0.7. So 1 minus 0.7. So that's 0.3. Let's verify. Greater than 0. So greater than 0 is 1 and 2. So that is 0.2 plus 0.1, which is 0.3. So that's correct. Now, let's have mean and variance. So for mean is equal to the expected value of x. So it is equal to the expected value of x. So the expected value of x, so is equal to mu. So this is equal to x times this is also equal to the summation of x f of x. So what we're going to do is to multiply all x's by f of x. So x times f of x. So we multiply x times f of x. So we do that for all values of x's and f of x's, and then we take the sum. So adding this up, so we can have the mean to be equal to negative 0.4. For the variance, variance is designated by v of x. So this is equal to, our symbol for variance is sigma squared. So the variance is equal to the summation of x minus mu squared f of x. So x minus mu squared f of x. So that would be equal to this is equal to, so to continue, that would be x. So we look for x. So that would be x minus, so minus negative, so plus 0.4 squared times the probability. So we do that for all the terms, and then we take the sum. So we add this. So this is x minus mu squared times f of x. So the variance is 1.64. Another formula is the expected value of x squared minus mean squared. So what we do is to get x squared times f of x. So we square x and then multiply it by f of x. So we do that for the entire table. You check, negative 1 squared is positive 1 times 0.4, 0 squared times 0.1, 1 squared times 0.2, so I think this is correct. So we add that. So that would be equal to 1.8 minus negative 0.4 squared. And then we evaluate that. What's the value of 1.8 squared? 1.8 minus 0.4 squared. So let's check. 1.8 minus 0.4 squared. So it's the same. It's both 1.64. So this is the mean and the variance. If you want, you can take the square root of that to get the standard deviation. You may pause to copy.